Hello everyone, welcome back. In the last video, we learned how while loops work with one example of printing stars. In this video, we're going to work through a lot more examples. By the end of this video, you should feel pretty comfortable with how while loops work. If you're still a little bit unsure about how while loops work, then you can rewatch the video, try some variants of the examples that we've done in this video, or come up with some examples on your own, perhaps via some textbooks or via some online resources. So let's get started. Go ahead and open up while loop fun, transaction fun, and guess my number fun in gedit. We're going to work in all three of these files. The first thing I want to mention in while loop fun.cpp is I showed you two different ways to solve the same problem. One, starting our loop control variable I at 0 and counting up. One, starting our loop control variable at our ending value, num stars, and then counting down. Another way we could have solved this would be counting up or counting down, but instead of starting and stopping at 0, we could start and stop at 1. So I want to go ahead and show you that now. Instead of ending at greater than 0, we could end at greater than or equal to 1. And we'll still get 5 stars. Let's do the same thing for our counting up example. We can initialize I to 1. We just need to go 1 further, since we're starting 1 further, and end at I less than or equal to num stars. And I'll need to add an initialization for I as assigned num stars down here. So there are 4 different ways that we could solve this problem using a while loop. In fact, there are a lot of different ways to solve problems using while loops. Doesn't necessarily mean one is wrong and the other is right, or one is better than the other. In future classes, you'll learn about the efficiency of algorithms and how to make your code as efficient and optimal as possible. And in that case, algorithms can be compared to try and figure out if one is better than the other. But in this class, we're okay with solving problems using code so long as our code is correct. So any of these solutions would be equally fine. In fact, we're going to work through a few more examples today where we'll see there are multiple ways to solve one problem. And all of the solutions are just fine for this class, but we'll start to see that maybe some are a little more efficient than others, but that's okay. So let's take a look at our first example problem. We want to write a program to print the first 20 even numbers. And I've given you the first 20 even numbers here in parentheses. So that would be 2, 4, 6, all the way up to 40 inclusive. So go ahead and pause the video, and working in whileloopfun.cpp, go ahead and code up a while loop that can do this. There are multiple ways to solve this. Go ahead and try it out and see if you can come up with one of the ways to solve it. So I'm going to go through 3 different ways to solve this. Perhaps you'll see one of your solutions in here, but if you want, you can pause the video before I go through these and see if you can solve your solution a slightly different way. All right, so let's go through the first one. The first one, we'll start I at 2 because 2 is our starting number, and we'll continue while I is less than or equal to 40. Because I is our ending number. Or excuse me, 40 is our ending number. We'll print out I and a space, And then we mustn't forget our progress towards our Boolean condition being false. So since our numbers go up by 2 in our output, let's just add 2 to I. And there we have the first 20 even numbers. Now let's try solving this a slightly different way. Let's say we still start I at 2, and we still take I from 2 to 40. But let's say we increment I by 1 each iteration. So we're just going to count 2, 3, 4, 5, 6, 7, all the way up to 40. But we're going to have to test to find out if I is even before we print it out. Do you have any ideas about how we can figure out if a number is even or not? There's a little trick that we learned a little while ago when we first learned about the mod operator. Any even number when modded by 2 will have a remainder, or excuse me, will have a value of 0. The remainder is 0 because 2 will go into it evenly. So if I mod 2 equals 0, then we'll see out I. And recall that if the body of our if statement, or even while loops as well, only has one statement in it, we don't have to use curly braces, though I think it's good practice to do that anyways. Wonderful. So now we've got 2 different solutions to solving our first 20 even numbers problem. Let's do one more. Let's start I at 1 and continue while I is less than or equal to 20. So this will take us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, which are not the numbers that we want, but they are the numbers that we want divided by 2. For example, 2 divided by 2 is 1, our starting number, and 40 divided by 2 is 20, our ending number. So to undo dividing by 2, we can multiply by 2. Oops, and I want to put this as a space, not an endo. That way our output is more compact and we can compare our output from each one of our while loop solutions for similarity. Great, so we've just solved our first example problem 3 different ways. I mentioned earlier a little bit about efficiency of algorithms. Well, one thing that I will note, while all 3 of these solutions are correct, this one right here is slightly slower than these other 2 because it's going to iterate 40 times, whereas this one only iterates 20 times and this one only iterates 20 times. So we could say that this solution, while correct, is actually twice as slow as the other 2 solutions. All right, let's head over to transaction fun, which was our motivating example for why we should use iteration in our programs, and let's rewrite it so that it does use iteration. So we have a constant integer num transactions, which is set to 5, and that's how many transactions that we're going to read from the user. But we don't want to read from the user by copying and pasting each time we need to get a transaction. We want to read from the user using a loop. So let's go ahead and add that code to make this into a loop. we'll need a loop control variable I, and we'll want to loop while I is less than num transactions. Each iteration of the loop, we're going to prompt the user for a transaction amount, read in that transaction amount, and accumulate it in our total transaction variable. One thing we want to note, we are missing our progress towards our Boolean condition being false. We want to add 1 each time so that we get closer to num transactions with I. Let's go ahead and save, compile, and run this. And we should be prompted for 5 transactions. One, two, three, four, 5. There we have it. So do you see how much shorter our code got by using that while loop? And now we can really simply modify our code by just changing num transactions right here. Maybe we need 10 instead. Or if instead we were going to prompt the user to say, hey, how many transactions do you want to enter? We could get that value from the user and use it to control our loop. So let's try that. Let's comment out our constant integer and declare another integer that's not a constant that will get this value from the user. So now at compile time, we don't even know how many times this loop is going to run. It's going to be based on an input value from the user. So let's update our Boolean condition to use that input value from the user. This is pretty powerful code now. It's very adaptable based on what the user wants. And that is right. We are no longer using num transactions, the constant. We're using num transactions, the dynamic integer. Let's say I only want to enter in 3 transactions. I should be prompted to enter in 3 transactions. And there we have it. And our average transaction amount is based on the 3 that we entered in. Awesome. Transaction fun is now using a loop, which makes our code much, much more versatile. All right, our next example, back to the guess my number game. Now we're going to see an example of a while loop where we're going to use a Boolean condition that is not based on a counter variable. Instead, it is based on evaluating some kind of flag variable or a variable that denotes whether something has occurred or not for true or false. So we're in guess my number, fun.cpp, and we want the user to be able to continue guessing until they guess correctly. So in the case where they guess incorrectly, we give them a hint. They should be able to use that hint to make another guess. So we're going to go ahead and add code to do that. Let's add a bool variable called guessed correctly. Now, if we name our variables such that they're indicative of what value they store, we can make our looping code self-documenting, such that when we read our while loop's Boolean condition using a well-named bool variable, it makes sense exactly what our while loop is doing or what it's looping until. So initially, the player hasn't guessed correctly. So we'll set that to false. If we ever find out that they do guess correctly, we'll set this to true. We find out right here when BC1 evaluates to true that the user has guessed correctly. So we'll want to set guess correctly to true. Now we've got our loop control variable all set up. All we need to do is use it in a while loop and put all of this code here to be the body of our while loop. So let's do that. While not guessed correctly. While the user hasn't guessed correctly, we're going to prompt them to enter their guess. We're going to get that guess with a cin statement. And we're going to check their guess for correctness. If it's correct, we'll set guess correctly to true, which means not true is false, and our while loop will terminate. Otherwise, guess correctly will remain false, and we'll give them a hint. We know that the secret number is 4 because we've hard-coded it to be 4 here. But we're not going to immediately guess 4 because we want to see if we can keep guessing until we guess correctly. So let's say we try 8. And it says you are too high. But look, our program didn't terminate. We get to guess again, which is awesome. Okay, so if 8 is too high, maybe we'll try 2. Which we find out is too low. Okay, well, let's try 6. Too high. Try 3, too low. 5, too high. So it must be 4. We enter in 4, it tells us that we guessed it, and our program terminates. This is great. Now our user can play Guess My Number until they correctly guess the number. Our program is almost completely functional. The only thing is it's always 4 or whatever we hard code it to. So very soon we're going to come back to Guess My Number fun, and we're going to add more code to it so that we can have a random number instead of a hard-coded number. Wonderful. This is a really great example of a while loop, and it's slightly different than our previous examples because we're not counting anything. We're instead using a general Boolean condition that is based on something called a flag variable. Flag variable, you could think about it like a flag in a race, like a go-kart race, and it's used to denote some special condition has been met. Like in a go-kart race, perhaps last lap, or someone's injured, or it's the end of the race, right? That flag comes out only when a certain condition is met. And that's why we use flag variables in our code in order to make Boolean conditions evaluate a certain way when a condition is met. All right, we are cruising. We've got one more example to work through, and then we'll call our while loop examples video good to go. Menu systems. Oftentimes we will write a game program, and the user needs to select from a menu. Here's a really simple menu. You might have seen a menu similar to this perhaps when playing a video game or an arcade game. So we can view the rules of the game, play the game, view the high score, or quit. This menu will continue to be shown until the user wants to quit. So you can see that loop structure kind of writing itself, right? Continue showing the menu until the user wants to quit. So let's go ahead and code this general menu system up It's not going to be for a specific game. In fact, there's not going to really be any rules, nothing to play, no high score, because we're just focusing on the menu system. But you could see how you could apply this menu system to our Guess My Number game, for example. Or really think of some common board games that you might have played growing up. You could implement those using C++ as a program and use a menu system to drive the user interacting with your program. So I'm going to copy these and then head over to While Loop Fun. Or if you want, you could add this code straight to Guess My Number. But I'm going to put it in While Loop Fun just to keep things simple. So let's wrap this information in cout statements. We'll probably want to put either a number or a letter on each one of these options so that we can prompt the user to simply enter in a letter or a number, denoting their choice for what they want to do based on the menu. And the last cout statement I'm going to add here is going to be the prompt for their choice. Great. So now I've got my menu all coded up, but it's not part of a looping construct, so it's not going to keep showing until the user enters in 4 to quit. Or maybe you coded yours up so that you use letters, maybe Q to quit. All right, so we're going to have a while loop in order to continue showing our menu until the user enters 4 or Q to quit. So we've got to figure out what goes in this Boolean condition here. Okay, so we could use a flag variable like we did in our Guess My Number Fun code. We could also just use a variable called choice that we read in from the user and compare that for inequality to 4. That would work as well. Either one of those options would get the job done. So let's start without using a flag variable, and then we'll add the flag variable just to see how, in my opinion, I think flag variables make the code a little bit more easy to read. So we're going to need an integer variable to read in the user's choice. We might have some code down here that tests to see what choice is, and based on choice, do something like add code later to show the game rules. Because remember, we're just focusing on the while loop here, but we could stub out some infrastructure for the rest of our game. If they enter in 4, then we might say something like, thanks for playing, see you later. Just something that implies that we know that they're going to quit our game. Okay, awesome. So this is good scaffolding for handling all of our different menu choices. It would be good practice to add an else here, just in case the user enters in an unrecognized number code. And we could let them know that nothing's going to happen because that's an unrecognized menu option. Okay, awesome. So when choice is equal to 4, the user wants to quit. So while choice is not equal to 4, the user wants to keep playing. So now's a good time to save, compile, and test and see if our menu system works. All right, so I'll do each option. Showing the game rules, playing the game, viewing the high score. Let's do option number 7, which doesn't exist. And it tells us so. And then 4 to quit. Thanks for playing, see you later. And our program does terminate. Awesome. One thing that I'm going to change, just because I think the output is a little bit hard to read, I'm going to add a new line character right before welcome to my game, just so that there's some nice spacing in between each iteration of our loop. There, that is much easier to read. Wonderful. So we solved this without using a flag variable, but I said we would come back and use a flag variable so you could see another way of solving it and see how flag variables are nice and make your code really easy to debug and to read. So I'm going to add a flag variable. I'll call it keep playing. The user wants to keep playing our game until they want to quit. So we'll initialize keep playing to true. And we'll set it to false when we know they want to quit. And we know they want to quit when their choice is 4. Now we can replace our Boolean condition with really, really short and sweet code. While keep playing. That's it. And that makes our code really self-documenting, right? If I read while keep playing, I have a really good sense of how this while loop stops. Keep playing somewhere is going to be set to false. That's the progress towards the Boolean condition being false. Right here. And I also know that this while loop is driving my menu because it has to do with continuing to play the game. Before, it looked like this, and we don't have any context for what 4 is. We'd have to go look up what 4 is in our menu code. Thankfully, the menu code is really close to the Boolean condition, so that's easy to look up, but that might not always be the case. So this here doesn't provide very much context, but this does. Go ahead and run through all your different options, including an unrecognized option, and make sure everything works. So in this video, we went through a lot of different examples of while loops, a lot. Hopefully you're feeling more comfortable with how while loops work. While loops are really versatile. You'll use them to solve any iteration problem that you may come across. The next iteration construct we're going to cover is a for loop. That cannot be said for for loops. You cannot use for loops to solve problems like this one, where We don't know in advance how many times this while loop is going to run, right? Keep playing might be set to false on the first iteration of the loop, the 10th iteration of the loop, the millionth iteration of the loop. We just don't know. So this is a good example of using a while loop to solve a problem where we don't know in advance how many times the loop is going to run. With a for loop, the for loop does need to know in advance how many times the loop is going to run. And we'll learn all about that in our next video covering for loops.